So today we're going to be discussing similar polygons. So we've been talking about congruent figures, congruent triangles, and all of the properties that go with those. So now we're going to shift a little bit to similar. Similar just means that the two figures have the same shape, but they are different sizes. So like our dilations. You can make it bigger, you can make it smaller, but it's the exact same shape. The order of the vertices in a similarity statement, so just like our congruency statements, is important. It tells us the corresponding angles and the corresponding sides. So just an example to remind you about the statements and how those represent the corresponding angles and sides. Similarity statement looks like this, very similar to that of a congruency statement. The difference is the symbol we put here in the middle. It's just a little squiggle that we used to have on top of our congruency statement, and that means similar. So then once we have that, then we can give all of the congruent angles. So we have A is congruent to E, B is congruent to F, C is congruent to G, and D is congruent to H. Then when we go to the sides, we're looking at a ratio. So the ratio of segment AB to EF, so those are the corresponding sides, should be the same as the ratio for all of the other sides. So BC to FG, BC is the middle two, FG is the middle two, so that ratio should also be the same. CD to GH, and DA to HE. Okay, so your ratio of one triangle to the other should be the same for all of your sides. Okay, so let's do an example. So here's our first example. We have two triangles here. We have triangle ABC and we have triangle DEF. Okay, so we're going to determine whether each pair of figures is similar, and we're going to justify our answer. Okay, so the first thing that we're going to be looking at is I'm going to look at the angles. So I see a right angle here. So angle F is congruent to angle, my right angle over here is C. Then we have angle D, that says 30 degrees, so that's congruent to angle A, which also says 30 degrees. Now if this is 90 and this is 30, that means this one has to be 60. We have our sum theorem, tells us that has to be 60. And again, 90 and 30, so this one has to be 60. So then angle E is congruent to angle B. So now that we know all of the angles, the corresponding angles are congruent, we're going to go on to the sides. Okay, so when we look at the sides, we're looking at AB. So we have AB, which is from 30 to 60. So that goes with ED. Okay, and that ratio is 12 over 9. So then if we go ahead and simplify that, we get 1 and 1/3. Okay, so let's look at some of the other sides. From the 30 to the 90 is AC. So from the 30 to the 90 it would be FD. So AC is 6 square root of 3, and FD is 4.5 square root of 3. Okay, so then if we go ahead and reduce that, we also get 1 and 1/3. So the last one that we have then is from B to C, the 60 to the 90. BC, 60 to 90 here is going to be EF. So BC is 6, EF is 4.5, and again when we reduce that we get 1 and 1/3. Okay, so since all of these ratios are the same, then we can say yes, those triangles are similar. And to be able to name those, I'm going to say triangle ABC is similar to triangle, CA went with D, so this is D. B went with E, so this is going to be E. And C corresponds to F, so then that's F. Okay, great job. Let's keep moving. So the next piece that we have is scale factor. So when you compare lengths of corresponding sides of our similar figures, then we usually get a ratio. So if you remember back here at our example, we were comparing those corresponding sides and we got a ratio, 12 over 9, 6 square root of 3 over 4.5 square root of 3. Those are all ratios. So we get a numerical ratio. That ratio, we also call that a scale factor. That is the scale factor for those two shapes. So we're going to do another example. This one's a word problem. It says we have some special effects in movies that are created using miniature models. So there's been a recent movie that used a model of an SUV. The SUV was 22 inches. Okay, it was created to look like a real SUV, which is 14 2/3 feet. So we're going to find the scale factor for the model compared to the real one. So the first thing we have to look at is our labels here. We have inches to feet. Well, those need to be the same. So we're going to take this 14 2/3 feet and we're going to put that into inches. Okay, I want to know how many inches that is. So we're going to take 14 2/3 times 12. There are 12 inches in 1 foot. So we end up getting a total of 176 inches. Okay? Alright, so from there, we're going to have the length of the model over length of the real. Okay, because it said model compared to real. So model over real. So the model was 22 inches. The real one is 176 inches. So then from there we're just going to reduce that to lowest terms and we get 1 over 8. So the ratio of the two lengths is 1 over 8, or we can write that as 1 colon 8, which means the same thing. And that is our scale factor. That is our scale factor. Okay? Great job. Let's keep moving. Excuse me. So I have another example here for you. The two polygons are similar, so we're going to write the similarity statement first, and then we are going to find the scale factor, the value of x, y, and ut. So first is our similarity statement. So if we look at these, I'm going to go around. I see there's 1, 2, 3, 4, 5. So I'm going to write my similarity statement that way. So R, S, T, U, V, similar. So then I'm going to do the same thing down here. I'm going to start with 1 is A, 2 is B, 3 is C, 4 is D, and 5 is E. Okay, so that's my similarity statement. So now I'm going to come down here. I'm going to be working on scale factor, x, y, and ut. Okay, so scale factor, we know we can go from 1, the model, to the real. So for this one, I'm going to be going from the first picture to the little picture. So I'm going to take ST, because I know that amount, that's 18. And then the corresponding side on the other shape, I have from B to C. Okay, and I know that one is 4. And those are both in meters. So then I'm just going to be simplifying that, and I get 9 over 2 is my scale factor. Alright? So then from there, now I'm going to be trying to find my x, my y, and my ut. So x, I see x is here. So x is RV, and the corresponding side is AE. So x over 3. Now if you remember, before we said scale factor needs to be the same for all of the sides. So this x over 3 has to give me the scale factor that I found up here at the top. So in order to do that, I'm going to set it equal to 9 over 2. Okay? So then from there, I'm going to just be solving for x. So I can take 9 times 3 is 27 equals 2 times x, which is 2x. Okay, so I'm just cross multiplying. So then from here, I'm going to divide by 2. So we get x equals half of 27 is going to be 13.5. Okay, so I'm getting x equals 13.5. And like I said, all I did here to get my equation is I cross multiplied. 9 times the 3, x times the 2, and then solve for x. Alright, so let's try the same thing for y. I'm going to slide down a little bit here. So for y is here at ut, so I have ut over, the corresponding side is cd. Ut says y plus 2, and cd says 5. And we know that has to equal our scale factor, which is 9 over 2. Now I'm going to do my cross multiplying. So I have 9 times 5 equals, cross the other way, 2 times the y plus 2. Okay, so I'm going to go ahead and slide up here so that way you can see what I'm doing. 9 times 5, we have 45, equals, I'm going to distribute here, we have 2y plus 4. So then to solve y, I'm going to subtract 4 from both sides. I get 41 equals 2y. Next is to divide by 2. Y equals 20.5. Okay, so I have my x, I have my y. The last one was to find ut, and we know ut was here. That was our y plus 2. So since we already have ut written down as y plus 2, I'm just going to copy that down. We have y plus 2 equals ut. We know y is 20.5, so I'm going to plug that in. 20.5 plus the 2 equals ut. So I end up with 22.5 meters equals ut. Okay, so I'm going to go back up to the top. We were asked to find the scale factor. We have the scale factor. We were asked to find x. That's 13.5. I'm going to put my label as meters. We were asked to find y. That's 20.5 meters. Okay, we found that down here. And then the last one, we were asked to find ut. We found ut as 22.5 meters. Great job. Let's try another one here. It's another word problem. So we have a triangle. ABC is similar to triangle XYZ with a scale factor of 2/3. If the length of the sides of ABC are 6, 8, and 10, what are the lengths of the sides of XYZ? Okay, so we know our scale factor. We can have AB. AB corresponds to XY. Okay, we can also have BC. Last two corresponds to YZ. And then AC corresponds with our first and last, which is XZ. So they told us the sides are 6, 8, and 10. So that's 6, 8, and 10. And those are inches. And they also told us the scale factor, so I'm going to put here, this is going to be x, this is going to be y, this is going to be z, because I don't know those yet. But I do know my scale factor is 2/3 for each of these. So then, just like we were doing before, we're going to do our cross multiplying. So I have 2x equals 6 times 3. So 2x equals 18. Divide by 2. We get x equals 9. X is xy equals xy, that segment. The next one, we're going to do our cross multiplying again. So 2y equals 8 times 3. So 2y equals 24. Divide by 2. We get y equals 12, which is yz. And then the last one is z. Cross multiply again. We get 2z equals 3 times 10. So we get 2z equals 30. Divide by 2. Slide up just a little bit here. Slide up, and we get z equals 15. And z corresponds with segment xz. Okay, so what are the lengths of the sides of that triangle? We have them right here. And our label for our label for all of these is inches. So those are inches for us. Okay? So then our last one that we have, we're dealing with scale factor on a map. So this one has the scale on the map of New Mexico is 2 centimeters to 160 miles. So when you're looking at an atlas, or if you're looking at a GPS or anything like that, obviously it's not the same size as the actual state or the actual city or whatever, so it's smaller. So there is a scale factor there. For this one, we have 2 centimeters equals 160 miles, so we're going to be using that. The distance on the map across New Mexico from east to west through Albuquerque is 4.1 centimeters. Okay, that's on the map. So how long would it take you to drive across New Mexico if you drove at an average rate of 60 miles per hour? Well, the first thing we have to figure out is how many miles is it? If it's 4.1 centimeters, how many miles is that? Okay, so we have 2 centimeters is 160 miles. So 1 centimeter, so half of this would be half of that, which is 80 miles. Okay, so for each centimeter, we know that it's 80 miles. Well, we have 4.1 centimeters, so we're going to take 80 times 4.1 centimeters. Okay, when we actually multiply those together, we end up with 328. 328, and that is miles. Okay, this was our miles. So for every centimeter, we went that many miles. So we went a total of 328 miles. Okay, now they're telling us that we go at a rate of 60 miles per hour. So we're going to use a formula here. Distance equals rate times time. So this is distance, okay, rate, and time. Okay, so rate, miles per hour, and how long it's going to take you. Alright, so let's start filling in the things that we know here. We know our distance is 328 miles equals the rate which is 60, times the time, which we don't know yet. We don't know how many hours it's going to take us. Okay, so we divide by 60 on both sides. So we end up with t equals, I apologize, let me scoot down there. So dividing by 60 on both sides, so we end up with t equals 5 7/15. So we have, that's equivalent to 5 hours and 28 minutes. Okay? Alright, that is all for today. Have a good evening, and I'll see you in class tomorrow.